Good morning. I am Dr. Selvaraj, a retired senior scientist from Central Electrochemical Research Institute, Karaikudi. We have prepared some alternative binders. First of all, I will give you an introduction about the cement and cement manufacturing. Ordinary Portland cement is being manufactured at several parts of India. And the first prime, the leading manufacturers of cement is number one in China. Number two, India. Producing cement, it's a cost consuming and highly energy intensive, and it pollutes the atmosphere. To produce 1 ton of cement, almost an equal amount of carbon dioxide is emitted to the atmosphere. Construction industry, nearly 5 to 8% of the global green gas emission is being done by the construction industry. So because of cement, it's all causing the ozone layer damage. So it is a highly energy intensive, polluting, and it liberates high amount of heat also. So calcium oxide is a major component in this cement. It is used in nearly 1000 degrees centigrade is required calcium carbonate to calcium oxide. Nearly 65% of the calcium oxide is there in the cement. Because of these disadvantages, it is necessary to go for alternative binders. So in that respect, I have developed some of the materials which are highly suitable for some works and repair works and major constructions also. Now let us see one by one. Number one is the magnesium oxychloride cement. That is, magnesium oxychloride is the binder, and plus the sand. Sand is a binder. That is calcium oxychloride. And then here at the bottom you can see the magnesium oxyphosphate. Oxychloride means magnesium oxide plus magnesium chloride. That is called oxychloride. This oxyphosphate, magnesium oxide plus magnesium phosphate. All these three are mixed with the sand, and it is being cast in this upper mold and is being demolded and show you. Only 1 day time is allowed for setting. This is oxychloride, but here after it showed some cracks. You see, this is not suitable for any mortar or thing. It's just highly shrinkable. This is the rubber mold I have used for casting it. Yeah, you can see that. Yes. This is with the baby chips. The smaller size of river and the screened thing, sand we are screening, and then the residue of the small particles mixed with the calcium oxide, calcium oxychloride, magnesium oxychloride. This is also like this. It's coming like it is set, and it works very well. See here, it's all self-explanatory. All are magnesium chloride mortar with 50% sand, 50% fly ash. And this is oxychloride, magnesium oxychloride concrete, stone aggregates plus fly ash. That is 2:1 ratio. And here calcium oxide mortar with 50% sand, 50% fly ash. And that is also stone aggregates, fly ash. And here also you can see sand plus 50%, 50-50, magnesium chloride, magnesium phosphates, and this calcium oxide and calcium phosphates. This is magnesium oxychloride mortar, 50% sand, 50% fly ash with a closer view. The magnesium chloride plus magnesium phosphate, 50% sand and 50% fly ash. This also same is magnesium chloride and magnesium phosphate, magnesium oxide, sand and fly ash, 2:1. These are very hard materials. The magnesium oxychloride mortar, 50% sand, 50% fly ash. This is also magnesium oxychloride sand. Magnesium oxyphosphate plus sand. Oxyphosphates are white in color. Magnesium oxychloride plus concrete, stone aggregate plus fly ash. 2:1 ratio. Magnesium oxychloride plus sand plus stone chips. This is this one. Magnesium oxychloride plus fly ash. No sand is added. This also you see very good. Magnesium oxychloride mortar. These are various combinations I have tried with sand, fly ash and baby chips. This is calcium oxide, calcium chloride, magnesium phosphate, 50% sand and 50% fly ash. This is oxychloride concrete, stone aggregate plus fly ash 2:1 ratio. This is calcium oxychloride with sand only. Okay, you see in it's a light brown color. Okay. This is, you see, so far what you have done it, another there is a chemical binders we have used it. From here, we are going to use the clay and binder. Binder is a liquid. Here 176 for 300 grams of clay. I have used binder 176 ml. What is the binder? The binder is 100 gram PVA, polyvinyl alcohol, in 2 liters of water. That is the binder. Binder 100 grams in 2 liters of water, polyvinyl alcohol. Polyvinyl alcohol was is a white powder. It is water soluble. That has been taken. And this was cast on the round circular pipe, and it was heated to 65 degree for 3 hours. And we are getting it, this kind of circular thing, no shrinkage, no crack, and it is a very hard material. I got it. And similarly here you see the fly ash 300 gram plus binder 110 ml. For 300 grams of fly ash, 110 ml binder. The binder is again you see 100 grams of PVC in 2 liters of water, and it is heated to 65 degree for 3 hours. I get it material like this. It's a hard material. Similarly here also you see the binder is 100 PVA, 2 liters, heated 65 3 hours, same thing. So clay is 150 gram clay. Clay means malt morlanite. That is what commonly available here. That kind of clay is used, 150 grams, and 150 gram fly ash, and plus binder 130 ml. The binder is again here you see polyvinyl alcohol in 2 liters, 100 gram in 2 liters, and heated to 65 degree for 3 hours. You can see the material how it is. See clay and fly ash. That is the base material. The clay, here you see the clay plus borax plus binder. Borax is normally used for arresting the cracks. It won't allow for developing cracks. That is why borax is added. So the clay is 285 and 15 grams of borax means 300 grams plus binder 320 ml. Binder is again you see 100 grams of PVA in 2 liters of water. It is heated to 65 degree